This video is going to be on section 4.7, just finishing up section 4.7, doing examples 5, 6, and 7. One of the things that is really important here is what you see on the screen is the inverse properties. We'll talk about this as we're going along. Okay, so let's go ahead and start off with example 5. Now we are talking about, we're using those properties for composition of functions. All right, so a composition of function would be where you might take one function, find the value of one function, and then once you find that value, you place it into the other function. Okay, something to that effect. So composition of functions is taking two or more functions and using them in some sort of operation. All right, so we are talking about example number 5. In example number 5, the instructions are, if possible, find the exact value. So three different problems. We might do all three, maybe, I don't know. So here's the first one. Okay, so this is your composition of functions. I want to find the value of this. Once I find the value of this, then I'm going to apply it to the tangent. Before I move on, though, I've got to make sure that it does fit the rule that it gives us when it comes to the inverse properties. Okay, so I'm looking at tangent and arctangent. That's this third line right here. If you notice right here, the arctangent's inside the parentheses, just like this. That means the x is with it, so my x value is -5. It says here, if x is a real number, well, -5 is definitely a real number. Okay, that fits. And, well, we don't have this part right here. Okay, because we're not dealing with the arctangent of tangent. We're dealing with tangent of the arctangent. So we're dealing with this one right here. So we do fit. Our x value does fit the rule. Okay. What I want to do is I want to go ahead and find the value of the arctangent of -5. If I find the arctangent of -5, well, I've already got it there, but let me go ahead and just do it again. The arctangent of -5 is equal to -1.373. I'll take it out to 3734. Okay, so I know the arctangent of -5 is equal to -1.374. So now let's find the tangent of -1.374. And look what I end up getting. I get the -5. I don't really want that right there. Let's just go ahead and put -5. I did it again. I just want to put -5. Here we go, -5. Okay, so what does all this mean? Well, it means that if I find the tangent of arctangent of whatever number, the tangent of arctangent -5 in this particular case, then it's going to be equal to whatever that x value is. Okay, so it's equal to -5. All right, so that's the properties. The next one is I want to find the arcsine of the sine of 5 pi over 3. Okay, so let's take a look at where, looking at that one right there. The arcsine of sine y is equal to y. So we got to make sure that y falls within our interval. Now here's my y value here. It's at 5 pi over 3. 5 pi over 3 does not fall within that interval, but before I answer that part, before I finish off that sentence, let's figure out where 5 pi over 3 is. So here's 1 over 3, 2 over 3, 3 over 3, 4 over 3, and 5 over 3. It's about right there. I can keep on going one more third to finish off that circle if I wanted to, which brings up this. All right, so here's the but. All right, so my y value is 5 pi over 3. I want my y value to fall within that interval. It doesn't, but 5 pi over 3 is coterminal to this angle, negative pi over 3. So I can do this now. So based off of this information, now that y falls within the interval, it should be equal to whatever the y value is. So this should be equal to negative pi over 3. Okay, let's just test that. Okay, so sine of negative pi over 3, here's the angle. It has an ordered pair of that. So that means the sine value of this is negative square root of 3 over 2. Okay, so remember arc sine, and I want to know what the sine value of what angle gives me negative square root of 3 over 2. Well, guess what it is? It's negative pi over 3. So this is equal to negative pi over 3. I've been doing that all day today. It's equal to negative pi over 3. So sorry, I'm wasting time. So this is correct. Okay, so that's how the inverse properties work on this. All right, we're going to do one more. We'll go ahead and do that third one. And that third one is, we're looking at the cosine of the cosine raised to the power of negative 1 of pi. Remember, that's just the same thing as arc cosine of pi. So the cosine of arc cosine of pi, we're dealing with this one, the cosine of arc cosine of pi. Now, pi is going to be our x value. Does pi fall between negative 1 and 1? Well, really, if you think about it, no, it's not, or no, it doesn't. So in that particular case, this is undefined. Okay, so that is section 4.7, example number 5. I'm going to stop it right there.